Hello and welcome back to Compiler Programming. With the tokenizer ready and even able to produce pretty nice errors for us, it is time to actually start using it and try to get something out of it. So what I want to get to today, which might take a bit, is to be able to get a function that will just return to us a number. Right, it's basically the same thing that we more or less started when just starting out with JIT. We want some simple things that would be very easy to understand, very easy to verify, and we can figure out how they work. So for that, we, I guess, need to copy one of these tests into our main suite and start adding stuff here. So it should be able to parse a function returning as or returning an integer. Okay, this will involve quite a lot of things. So let's see how fast we can make some progress on it. Okay, first of all, we should remove this stuff. We also technically don't need /ns, I guess. This would be better for reporting stuff, but it is not strictly required. And here we would say 42. So here's the idea that I have for parsing part. And the idea is that we won't really do any in traditional sense. And instead, it will work more like pattern matching, which some people might still say is parsing. But it won't be a monolithic parser where we pre-specify all the rules for how to deal with all kinds of tokens. And instead, it will be composed of multiple rules that we sort of define ourselves. To start with, I want to actually probably open up a debugger and make sure that the tree here is exactly what I expect. Writing it out would be a bit too long for the test, but I want to do that. Once we have that, I would try to go through that token tree and figure out how we can recognize particular patterns in that tree and do some things about them. So in particular, if you look at this form, you realize that when we have a function, it is an identifier followed by this double colon followed by the arguments, but because our tokenizer is already nested, this will be just one token which we can very easily match on. We don't need to do some weird lookaheads or anything like that. We could just say it's a parenthesized group, right? And we don't really care if it is valid or not at the time that we are trying to understand if this is a function or is it something else. And finally, we have an arrow which signifies a function, and then we have this stuff. So I still haven't decided where would the return type go. I guess it will maybe go into here. I don't know. Also, there is a question whether this would be required, this curly brace or not. But we'll see. I think I will require curly brace always, but one thing that you notice is that there is no return keyword. And this is something I alluded to in very early episode somewhere, saying that I don't think that we'll need an explicit return for a while, and instead we'll just make all blocks return a value. because as we see in our tests, you basically always have a value. There isn't really a thing in assembly where you do an operation and you can't figure out what would be the output of that operation. You always sort of have some handle, and this is what we will use for the return result. So we don't need to figure out return keyword. We'll just say that we'll have this definition, and then we have this stuff. Actually, I will probably even start with this function so that it is even simpler. Function that, or like void to void. Yeah, this would be even better start. In this case, we should be able to match this pattern, and since there are no arguments and there is no body, there is absolutely nothing for us to do. So this would be pretty straightforward, I hope at least. Okay, so let's open up Visual Studio. And make sure that tokenizer provides the right thing for us. So I want to go to function spec. I want to go to the very top of the function spec and check over here. Let's make sure that our stuff is the right one. So we say function spec, and we can try to run this. Yeah, I guess I do need to build this stuff, which doesn't because we have not included source here. So let's do that. Let's include source. And then why do you fail? Yikes. So let's include it as the last one. Somebody else is a bit unhappy about this. Yeah, we can figure out later what is going on with those includes. For now, let's try to run this. Okay. And what I want to check is this stuff. So we have root. Root doesn't have parent. It is a module. We have children. And root children data items 0. Is it like this? No. Yes, it is like so. Yes. Okay, so the first child is an ID. That's exactly what I would want. Then the next child, I guess I can try to cast this to, what should it be? Token 5, will that work? Okay, I cannot cast it to okay, that doesn't really work. I need to figure out how to tell Visual Studio that it is 5 long. Does this work? Oh, great. Yes, so this works. Now we can actually look at these. So the first one is an ID, the second one is an operator, and the source is correct one. Then we have an operator. No, then we have a paren, then we have an operator, and then we have a curly one. So this looks very good. This is exactly what I would expect it to be, but it doesn't hurt to verify because, we don't want to spend time also realizing that our input data is actually not correct. Cool. So what do we do now? Well, for now, I will just start writing it inside of this test, and then we figure out how to extract it into something more usable. So the idea here, as mentioned, is to try to recognize patterns in the tokens. And that means that we need to somehow describe those patterns, and let's do something like array token function pattern is dynamic array make, and array token. Okay, then we push stuff. Okay, what would that look like? I guess we just give it also tokens. So we say function pattern token, and here we provide a type is token type ID. Okay. We don't really care about the source. What else do we want? So after it, we will have an operator. And here we actually do want a source. Say source is slice from from string literal. So we are looking for this stuff, right? Okay. And then we want parent. Okay, let's check. Array token is undeclared. That is perfectly fine. We can define one. So let's define also token array. We have pointer, but for pattern, it is better if it is stored as a value. Okay, so ID, operator, parent, then we would have another operator, which is this stuff, right? And then we have a curly. So this is our pattern. This is what we are looking for in the input. Now, we also should probably check that the root type is token type module. Oops. Okay. And this would be a good time to try to run the tests. Okay, all the tests are fine. This error is actually something that we left in here somewhere. Failure. Yeah, print message with location. So I'll just comment this out for now. Okay, everything is great. Now we have this stuff, we have a module, and that means that we are ready. Actually, we can probably move things around and put this stuff below, because this pattern will be defined somewhere globally in our compiler. We will just have these built-in patterns that it uses, but eventually I want to allow users to define their own patterns, and this stuff will become more complicated later on as well. But for now, this is all we need to do. Okay, so what are we going to do? Well, the idea here is once we match these pattern, we need to do something about introduce something with it. And for now, I will just kind of remove it from the tokens, which, or more precisely, I will just skip those tokens and say that we are done. Okay. So for U64, I is 0, I less than the array length of root children. And here we need to do another loop. So let's maybe not call this I, but rather token index and token index, and we say token star token is root children dynamic array get. Okay, this is our token that we are looking for. And then it's a pretty standard dumb search loop, which is something that has to be improved at some point later on, but for now we just want to make it work. So let's call this maybe source token, and here we would have a pattern token. So we have here function, pattern, and function pattern, and this will be pattern index. So I guess the other one should be called source index, not token index. Okay. Yeah, this is not I, this is corresponding index. Okay, it complains that we are not doing anything with those things. Well, what do we want to do? For now, let's do the simplest thing and just say that the only thing we expect inside of the source is exactly a function definition. There can be nothing else. That means that if any of the tokens doesn't match what we are expecting to, we will just say, nope, sorry, that's wrong, and we will exit this loop. So for that, we'll need to have this thing at the end. And here we say, and now we need to do the match. So the way I imagine this, if you notice here, we don't define the fields that we don't want to match on, which means they will be initialized to 0 in C, and we can use that to figure out which fields we care about. So let's start with the type. So if pattern token type, and let's verify, but I think, yeah. So this is why it is very nice to start with 1 here, because we can use 0 as a sentinel value and do actions based on that. So if pattern token type and pattern token type is not source token type, then we have a problem. In particular, we need to say check or even, yeah, for now let's do assert. Third, mismatched pattern. Again, we'll figure out later how you want to deal with errors and how to propagate all of that to the user. For now, this is just about the logic. So if we have a type and it's not the right type, then we are exploding. If we have source length and not slice equal pattern type source token source. So let's split up this on multiple lines so it's not so long. Okay, so this is pretty straightforward, right? We just see if something is defined in the pattern and verify that we are in the right place. Let's see how that goes. Yeah, here we actually store pointers, so we need to do a star. Well, let's try to run this. Ideally, this should match correctly. Okay, apparently it does not. So let's see where we are exploding. That is fine. Okay. So we definitely want now source token and pattern token. Can I somehow increase the size here? I should look into Visual Studio how to increase font size. I don't know. We'll figure out it, I guess, between the videos. Okay. We have source token and we have parent token. Oh, sorry. We have this stuff. So type is ID, type's ID. So we expect this to match. This is fine. Okay. Pattern token source length. So this should be skipped. It is fine. So the first one matched. The second one is okay. Yeah, so I do know what the problem is. We do not need this loop. We will need it eventually, but for now we don't. So let's just say like so. And now we are ready to try again. Great. So we managed to match the pattern. And now we need to do something about it. Okay, so what do? We need to definitely extract this name somehow, and we need to create a function. So actually we don't even need this name strictly yet because we don't care about the scopes at all at this point, which means as soon as we have matched the function, we are ready to create one. And how the way we can do that is, well, this will be very uninteresting because we just essentially say this, right? We say function matched, and that's it. However, there should be stuff happening inside. So first of all, yeah. So this is all there is to kind of empty function until we start dealing with names, or until we start dealing with multiple functions or any other kind of syntax that happens. For now, we just verified that this stuff exactly matches our pattern. Now we can start putting things in. So first of all, let's put 42 into here. And we can change this to be like so, I guess. It still should match because we don't actually look at the children, right? We just want this stuff to be what we want. This is a place where dealing with C is a bit annoying because ideally you would really want pattern matching, but that's fine. We can deal with it ourselves. So once we meshed the pattern, we are ready to kind of disassemble it in pieces and start dealing with those pieces individually. So first of all, we say that slice ID is how should I do it? I'm just thinking what would be the nice interface long term. When you match a pattern, maybe what you want to get back is the pattern itself. That's an interesting question. Like once we extract this stuff into a function, like what would it return? Maybe it either can return us an index at which we match the pattern, and then starting from that index we just go to the pattern and extract things one by one, or it can return us the actual match right away. I'm not sure, to be honest, what would be the best option. For now, let's assume it will return us an index, and then we figure things out. So right now we hard-code it, so match index is 0 since we are starting here, right? ID would be root or star dynamic array get root children match index, and then we have source. So let's see if I figure this out correctly. That should be like this, I guess. Okay, that's fine. So we have an ID. We can check that this is slice equal ID string from slice from string literal. Nothing. Or let's call it full. Okay. Cool. So we are able to extract this stuff. Next, we want, we basically don't care about this colon because it doesn't do anything for us. For these particular tests, we want to verify that there are no arguments. So let's do that. We can say token star args is this stuff. Plus 2. So this is the awkward part. And this is why I was thinking, like, how should we deal with the match? Like, what should be returned back? Maybe we will turn all of these stuffs into functions, and they will just return to us an struct with all these fields, or a null if they didn't match, and then we just go through them one by one. I don't know. We'll see how that goes. Like what I'm doing right now is not at all standard compiler programming stuff. It is something of an exploratory thing, so expect quite a few head scratches and things that don't go according to plan. But this is fine. Okay, so we have args, and we want to check that there are no tokens within args, right? That we don't have any arguments. So we say dynamic array length of args is 0. Args, and we also want, well, yeah. Okay. Good. So we don't have any arguments. And now we come to the funky part. So we came across this thing. And now we need to do something about it, right? We need to figure out what goes inside of this block. And this is where we would need to do something here, right? So we created our function, but we need to make it return things to us. So we say body, and this would be +4. Now, another interesting topic will be here. If we make a return type optional, then we would have a situation where our pattern would have to also be able to specify optional arguments, which means we will go into territory of regular expressions. So for now, I'll just say, let's ignore this topic. It's not impossible, and I've written regular expression like things before, but it's just not something that is very easy. Maybe we will force people to write this stuff for now. So like it gets nothing and it returns nothing. And if you want to return something, well, you will write something here, or like, I don't know, string. So maybe that is actually a good idea. Let's do that. So it's very easy for us to add this pattern, and it will allow us to say what we want to return. Not that we know what to do with this for now, but we can figure that out. Okay, so let's write a to do and say to do check return type. Yeah. I don't know if I want to have that. Okay. Body. This is the interesting part. We have 42 and we need to do something about that. So we need to figure out how to deal with the body. And with any parsers, including this one, it is all about recursive stuff. So we will need to do different kind of matching, which will be way more involved eventually. So we'll need to figure out how to reduce arbitrary expression to something that we can describe in these kinds of terms, right? So we'll recognize some pattern in that expression, and then we will do some actions in our compiler accordingly to what we recognized. So in this particular case, we just say, okay, we only have one value, and that value is what we want to create. And if this is also the last value in the block, then we implicitly say that the result of the whole block is this stuff. For now, we're gonna do all of that inline. So first of all, this one will be +5, I guess. Yeah, this is very awkward, and I definitely want something else to happen there. But for now, it's fine. Okay, we have the body here. We want to say that, okay, there is one child in there. And for now, we will just hard code that child. And let's actually move all of this into here. Because when we actually get the arguments, we will just turn them into these kinds of statements, right? And this would be, or at least should be, pretty easy. For the return type, we don't explicitly write return type in these functions either. So it is fine if we do it like this. Okay, so this eventually, let's say, fix me do recursive expression matching, but for now we want to do the minimal possible thing to make our tests pass, which we still need to actually make. So let's see, function type void to S64. And this would be checker. Value, yep. And we check that checker is 42, right? This is what we are trying to get to in here. Now, if I try to run the test, it will assert somewhere or fail. Yeah. So, yeah, the first thing that it's missing is it's missing this program end. So this is why it asserts right now, but there will be way more things wrong with it. Okay. This is not at all where I would expect it to assert, but that's kind of interesting. Why did it assert there? So it really didn't like the program end stuff. I guess it doesn't like an empty function. So let me just try something before we go into rabbit hole of debugging that stuff. Let's just say that I will do this stuff. Does that work? Yeah. So we really have a arithmetic problem somewhere, and I will remember to debug this stuff separately. For now, our goal is to put something here. And in here, we need to do what? Well, if you think about any expression, you have... So let's just talk about this for a second. Imagine you have something like 42 plus 3 times 2. When we are looking at this expression and we're figuring out what to do about it, we have the concept of precedence, and we know that 3 times 2 should happen first, and then you have plus at the end. But from the standpoint of this parser thing that we're going to be writing, it will go through this expression and, as I said, do this pattern matching. And these patterns will also have a precedence. So first we'll try to match patterns with the biggest precedence, and lower and lower and lower and lower. So if we have a pattern that says something like this, so these are our patterns in precedence order. Right? So we have this stuff, and then we have, I don't know how to specify it, like integer, and these are on the same thing where we have, or let's just say integer or paren, right? So first we try to look for multiplications, and we try to look for additions, and then if we fail, we try to look for one of these. So the way this should be processed in steps eventually, probably not in this video, but eventually, is it should go through this expression and start matching in this order. So it's like, okay, I have something here, right? That's fine. But then I try to match with the multiplication sign or star, and doesn't match. So I continue further, and I try to, I start here, I try here, okay, that doesn't match either. So then I try here, and I try here, and it matches. But this underscore on the left and the right side means that whatever there is also an expression. So then on the left, I do like 3, and I try to match it with this stuff and try to match it with this stuff. None of it matches even by length, so this would be extremely fast match. Okay, this just doesn't work. But it is an integer token, so we know what to do with integer token. We need to transform it to an integer. The same thing happens to the other side, and then we are sort of going to be substituting this whole thing with something else. And that something else is a value. So in general, what we expect that the whole pattern matching process is supposed to turn an array of tokens into a single value, or no values at all, maybe. Although if we're talking about the module, we will probably want to represent modules as values eventually as well. So I guess expression evaluation should always result in a value, even if that value is like nothing. We might just use void type for that or something like this. It doesn't really matter how we decide to figure out nothing, it will still be there. Anyway, this is a long and windy explanation about what we eventually want to do. All I wanted to say here is that at the very bottom, there is this part where we just go through the token stuff, token list that we have, and if it matches an integer, then we are good. And this is what we can encode. So this should actually be like this, and we say if, and now we can say if. So we first extract token, expression is body dynamic array get of body children and 0. We want to do this stuff here, and then expression type is token type integer, else assert unexpected or unexpected value or something. We figure out errors later. Okay, so we found an integer. Now we need to do something about it. And this is where it becomes a bit awkward, because C built-in functions, they don't really like working with these slices that we have. And to remind, slice is basically just a pointer to some array of bytes and the length of that array. So you can also call it Pascal string in other places, but this is a basic idea. And when we want to convert an integer to an integer string to an actual integer, we need to pass it to a function. And the easiest way to do it probably is something like a scanf, but as scanf doesn't really give us a way to say what is the length of the buffer we are pointing to. It expects that buffer to be a C string. So we have basically a couple of options. We can create a custom string and pass it there, or I don't know, or we can do it ourselves. And I think I even have a routine to do it ourselves, so we can probably take a look at it. Slice, yeah, actually I do have a very dumb and inefficient routine to do this conversion, but this is what it looks like to turn a string into a number. Essentially, actually this should be not int, should be S64, so it's good that I looked into here. Yeah. You start with 0, you go from right to left, and then you check that the digit is correctly actually a digit. You get what would be the corresponding number. So this is an ASCII byte, but in ASCII encoding, 0, 1, 2, 3, and so on, they are have continuous codes. So if we subtract the code of 0 from the from our character, we will end up with 0. If we take ASCII character 1 and we subtract 0, we end up with number 1. So this is what we are doing. We're converting a character to a number, and then we multiply by the current 10 power. So we start with power 1, then we have 10, 100, 1000, 10,000, 100,000, and so on, right? And we just go from right to left and doing that. At the end, if we found a minus, then it is just a negative number, and we inverse that number. And that's about it. I returned the special value. That's also something I like more than what C does, where it would indicate like how would you even indicate that parsing succeeded if you already use a number. So that's that. Okay, so we can use slice parse s64 in our code, and we can do that. So this returns list stuff. Parse result is slice parse 64 of expression source, and yeah, that's just that. We want to assert that parse result success. We assert that parse result value is 42. So let's see if our test succeeds now. Oh, I mean it fails, but it doesn't crash. Let's put it this way. It doesn't succeed because here we are returning the wrong thing, right? So this is good. And we say value star body result is a 0. Here we want to assert that there is a body result. And here we just do what we were doing here, where actually we might not want to assert if we want to return void. Yeah, actually this is fine, and we should say something like if body result, then return body result. So something like this. And now that we have parsed this, we have value from body result is value from S64 of parse result value. Okay. And it does pass. There is nothing really complicated here, and a lot of it is placeholder code that doesn't really do much, but I still wanted to kind of go through this process and showcase something end-to-end, because if I try to make all of this work in one video in a proper way, it would never finish. Like it will probably take us, I don't know, 10-15 hours to get to the place where all of these would be structurally like how it's supposed to be in the end. And also additionally said I'm not entirely certain about how to best structure this stuff over here. So this is something to think about. And additionally, there is also a problem that when we are substituting, for example, when we will need to substitute this multiplication by something else, we need to have sort of tokens in values in the array at the same time, and this is not really something that we have right now. So this probably will be a next video where we figure out how do we do these things more thoroughly. So maybe in the next video what I will do is I will actually it's supposed to be S64, and I will do is we will do one change, and this will be a very uncomplicated change that, to make from the standpoint of the user, but it will be very complicated to implement, where we would start figuring out how we deal with things like this. For now, this is the basic setup that we're gonna use. So we tokenize stuff, we then start to pattern match, and at the module level, I think for a while, the only thing we'll have is functions. So right now we're matching only one function, so eventually we will match multiple functions. And then once we match a function, we will create it. One more thing that is going to happen has to do with scopes and looking up identifiers. So this is also something that just does not exist at the moment, where we have this foo and we verify that we actually got the foo, but we don't use it for anything, right? So we can't specify it as an entry point, we can't export it from these things very easily. So there's definitely lots of stuff to do. But that would be it for today. Thank you very much for watching, and hopefully see you next time.